Okay, can everyone see my screen? Okay, great. I just want to get the chat out here so that we can ask questions and answer questions and stuff like that. So if anybody has any questions throughout, please feel free to put them in the chat so that I can answer them as we go. Otherwise, there'll be some time at the end for some questions. If you have used Angular before, please feel free to post it in the chat. And just so I know, yes, you will be getting the slides at the end. I can send the link to the slides to the organizers, and then they can send them all to you after. I'll just publish them for everybody. Okay, so today we're going to be talking about Angular, the light and the fun way. So if you've ever used Angular before, or been in the web development discourse, Angular has been known in the past to have quite a bit of boilerplate, just like extra code that's needed to do the simple things. But modern Angular actually has been making a lot of changes towards this to improve it. With their standalone APIs, inject functions for their dependency injection system, and single file components. So we're going to go through and talk about each of these concepts. And then what we're going to do is we're going to go do some live coding and actually build a simple Angular app the old way, and then convert it to the new way so we can see the reduction in code and how much simpler it is to build and reason about with all of these new features. I thought this was a pretty apt quote: "Simplicity is the ultimate sophistication." Just because all of these APIs are simpler in the new version of Angular doesn't mean that they're less sophisticated or less powerful. They actually are more powerful in a lot of ways. So who am I and why you should listen to me? Maybe that will be up to you. I'm an Angular GDE, so I'm a Google developer expert for Angular. I'm recognized by Google as an expert in the field. I'm an open source contributor. I've contributed to NGRX, Angular, and NX. If you've ever done any web development or JavaScript, TypeScript type development, you might be familiar with some of these tools. And then I'm also the CTO and co-founder of Charles.org. We've built a fundraising platform for charities. Okay, so Angular, the light and the fun way. So like I said, we're going to be talking about standalone APIs, inject, and single file components. So I already mentioned this, but Angular has improved the developer experience recently a huge amount, just based on the simpler functions, the patterns, and the APIs. Up until now, and still now, a lot of it has been class-based, but we're moving more towards function-based. So it's more just, plain functions rather than decorators and JavaScript classes and all that kind of stuff. Okay, so before we get too much into it, because I see that no one said they've used Angular before, just some basic concepts around what Angular is and the tools that Angular currently has to build. So Angular is a web framework, just like React or Vue or Solid or Svelte or something like that, or Quick is a recently released new one. So it's a framework to build websites, essentially. So at its core, Angular has some concepts. The component, this is the view layer. It defines what's rendered and how. It has inputs and outputs, event listeners for different buttons or click events, all that kind of stuff. ng modules, not JavaScript modules, but ng modules. These are now optional, and this is one of the things that we're going to be talking about here, is with standalone components and standalone directives, pipes, etc. Previously, a module was really like a dependency container. So you would define what dependencies things in that module had access to. Now with standalone components, you do this at the component level, and we'll see more about that afterwards. There's directives. So a directive is a class to alter or add behavior to DOM elements. So for example, you could create a directive for buttons that would style your button a certain way, or add additional behavior using JavaScript to the button or other elements like that. Pipes, these are reusable functions that can be used inside templates. So say you have some input to your component, but in the template, before you display that data, you want to format that data to look a different way or function a different way. Like maybe you want a number to not show any decimals. Just the kind of like a rounding function. You could create a pipe that does that for you. And then your template can just take in the input, transform it using the pipe, and then display it into the DOM rendered that way. And pipes can be pure, so they're memoized, which means that they don't need to be recomputed as long as their inputs don't change. We also have resolvers and cards. We're not going to talk too much about resolvers. We'll do a simple example of like a guard, but these are just functions that can run at different times during navigation. Saying, can the user activate this route? Resolve this data before we navigate to this route, stuff like that. And then services. These are reusable classes that exist within the dependency tree. So you could create a service for fetching your data from the server, or create a service for listening to a WebSocket, and then use that service throughout your application. And it can be injected into any of the above. Typically, you wouldn't inject things into ng modules, but you can inject it into any other Angular structure, for example. So standalone APIs, like I was mentioning before, we had this concept of ng modules, so you can see it on the left there. A while ago, before the concept of what's called single component Angular modules existed, people would just put a bunch of components into a single ng module and create kind of like a giant shared module. But then this concept of, they're called SCAMs, so single component Angular modules, came around, where you would have one module per component, or one module per directive, one module per pipe. And this allowed you to more cleanly manage your dependency graph rather than having one giant shared module that you would just import everywhere. Because that also made it harder for the Angular compiler to tree shake, optimize your dependencies to like lazy load chunks and all that kind of stuff, right? So we're just going to assume that the before was always using SCAMs. So there's always one module per component or directive or pipe. And then after, there's going to be no modules. So with the standalone APIs, what the Angular team actually allowed us to do was get rid of the ng module entirely. Internally, they kind of combine the two. It doesn't work exactly like that, but the way you can think about it is now the component acts as both. So you can see the code on the left. We've defined our component with a selector and a template. And then we've defined our ng module. Now, anytime we wanted to, if we would want to use the my component somewhere, we would have to import my module to be able to have access to my component. Now, what we can do is we can just get rid of that ng module entirely and just add that standalone true flag to the @component decorator. So you can imagine that. So for example, at Trellis, we have hundreds of components, maybe even thousands of components, right? We essentially duplicate that boilerplate code, or did duplicate that boilerplate code for every single component. And every single one had its own ng module and was managing its own dependencies and all of that kind of stuff. So it is a huge amount of extra code just in the repo. It's more code to manage. It's more code for developers to write, all that kind of stuff. So now what we can do is, by using standalone true, now everything that it used to exist in the ng module decorator just will exist in the component itself. So the component is the one that's responsible for defining its own dependencies, importing its own stuff, providing its own things to the dependency injection system. So you can see that it reduces the amount of code a huge amount. And typically, when you're following like a scam pattern, you would have two different files. You'd have one for the component and one for the module. So not only are you having extra code for the module, you're also having an entirely extra file for the component or the directive or the pipe, etc. So you can see how this would reduce a huge amount of code. Secondly, providers and the application. So not only did the standalone APIs introduced the ability to make standalone components. But now what we've started seeing and the Angular team has started doing with Angular is creating these essentially standalone functions that are lighter weight. They're not class-based and they provide better tree shakeability. So let's look at the left. So the left, we have two components. I've left out the component metadata just for brevity. We don't need to worry about, but typically there'd be a selector and a template, styles and all that kind of stuff in those decorators. But we have two components. We have our routed component and our app component. And then we have our app module. That's our base application module. That is what Angular is actually bootstrapping into the web browser. And then we have the code at the bottom, which is actually tells Angular to load that app module. It looks funny, it kind of is funny, but we'll see how it's changed over time. So we also have this in the ng module, we have the router module.forRoot. Previously with Angular, and this all still works. There's full compatibility between standalone and non-standalone. I should mention that. So you can use standalone components. You can import them into ng modules. You can import ng modules into standalone components and vice versa. Angular team's really, really good about maintaining backwards compatibility that way. But I'm just showing you before entirely and then after entirely switched over. So before, we'd have this ng module, bootstrap our app component. We would import the router module and then forRoot it. So modules typically have like a forRoot method, which you would call in your app module. And that kind of just like sets up some base classes and dependency injection and stuff like that. What this means is that everything included in the router module, there's a huge amount of features in the router module. There's all kinds of there's like debug logs and different hash location strategies and all these different things for managing websites. And like the navigation, for example, in this one, it's the router, right? So it would be all these different additional features for navigation. That means that the Angular compiler can't tree shake that stuff out because it's part of the router module class, right? So even if you're not using, say, a different hash location strategy, that still ends up in your final applications bundle because it's all part of the same class. Now, if we switch everything into the standalone APIs, again, we already went through the component stuff, right? So you just add the standalone true and no need for additional modules. But now what we can do is we can do bootstrap application. That's a little bit more clear than, platform browser dynamic function call bootstrap module, and then pass some providers to it. So provide router is the standalone API of the router module. But now all we're doing is providing the router. All of those additional features and stuff like that aren't going to be included in our bundle because we're not using them. We're able to tree shake out when there's multiple functions and a function isn't used, but we're not able to tree shake out multiple methods on a class and one of the methods isn't used, right? So now that we have all these standalone APIs for say the router, our bundles are actually getting smaller because not everyone is using absolutely everything. For example, there's a function of the router in Angular called tracing. And if you enable it, in your developer console, you'll actually see logs of absolutely everything that's happening in your router, like attempting to navigate, calling resolvers, checking guards, all like success, failures, everything, right? You obviously don't need that in production, nor should you have tracing enabled in production. But before, with the router module, it always existed in the bundle because you couldn't tree shake it out. Now, it's not included, so it's not used, which means it gets tree shaken out, which is pretty awesome. So the next thing we're going to talk about is the inject function. So this is dependency injection. If you're not sure what dependency injection is, at its core, it's just this system for defining a certain dependency and then allowing all of the entities in the tree to have access to that instance of the dependency, right? So instead of every component having to create another instance of a service every single time it's injected, instead, it just goes to the injector and says, give me the instance that was already created. So you can have singletons across the entire application and maintain state that way, which we'll actually see in our live coding a little bit. So with the inject function, let's just take a look at the left one here. So I have a token, an injection token. So in Angular, you can provide injection tokens, and they can be essentially of any type. Here we just have a basic string injection token, which means that we can use my token in components, directives, pipes, services, resolvers, guards, etc., as long as it exists in the dependency tree. So we're just providing a basic value, hello world, to the my token. So if I ever inject my token in this component and then say displayed into the DOM, it will say hello world. So the two ways to use this token are either with the inject function or with the old method, which is via the constructor. So with the constructor, you used to have to use the decorator at inject and then provide your token. The issue with this is that that's not type safe. Decorators aren't type safe. Angular actually uses a different specification than JavaScript because JavaScript doesn't even have decorators yet. I think they just got past the last stage with TC the committee. So we should see them soon. But these aren't type safe, which means I have to manually put that private token string there. And if I mess that typing up, my compiler can't tell me that it's wrong, which means I start writing invalid code. Like I could have put private token number there and that would compile. That's obviously not great, right? Because that's the whole point of using TypeScript. So what we can do now is just create a private member variable or a public member variable in this case called my token equals inject my token. Now the inject function, the lowercase I inject, not the decorator below, this is actually used internally by Angular and it recently became public API, but it's type safe. So it'll look at that injection token, look at its generic, which is the string here, and know that now my token is typed as string. Now my application is more type safe. And if I do an operation on my token, I want to call .substring or something on it, I know that I can because I know it's a string. Now with services, this also works for services. So on the right-hand side, we have my service, which we've decorated with injectable. That just tells Angular this is able to be newed and put into the dependency injection system, the dependency tree. So what we're doing here is we're providing it into the component, and then you can see the exact same case as we did with the injection token. We use the inject method, it's already typed for us. We don't need to manually type things. The inject function just handles it for us, or we have the constructor. So not only is the constructor more code, it can be less type safe, and like it's less type safe for the injection token for sure. It's not that bad for injectables, but it's still more code, and the inject function is just quite a bit cleaner. So that's the inject function in dependency injection. So now single file components. Up until, I think this has been able to be done for quite a while, but for the longest time, components were actually written in 3 different files. Now there was a 4th for the module, of course, but we're not talking about the module here. We're just going to talk about the components. So we had the component TypeScript file, we had the components HTML file, and we had the components SCSS file, or CSS or less, whatever you want to use. And then you would reference them all. So now, again, remember, like at Trellis, we have hundreds or thousands of components, right? So now what we have is we have a TS file, an SCSS file, an HTML file, and probably an ng module file for every single component. That grows out of control incredibly quickly, right? What we can do, though, is we can reduce this down to a single file. Now, I probably wouldn't do this for every single component. Some components this may not make sense for, like if you have tons of styles, you might not want every single style and you might want to break that into a separate file. If your template is unbelievably massive, that might be a hint that you need to break into separate components anyway. So there's no hard and fast rule. It's very opinionated on whether when to break components out. But you can see here that this component is now self-contained, right? In this example, we don't have the standalone flag here, so we would have an ng module file, but we can remove that ng module file and just add the standalone flag here. So now what we've done is reduced our 4 different files down to a single file for our single component, and everything is just self-contained within that one file, which obviously is a lot cleaner. And you have access to, you can visually see all of the related code together for that. Okay, so I know I kind of whipped through that a little bit, but let's go and see this in person. And then what we're going to do is we're going to build it using some of the old techniques. And then we're going to come back and we're going to refactor it into the new standalone APIs, inject functions, single file components, stuff like that. So I've generated this basic project. Can everyone see the size of this? All right. I'm not sure how large the font is for everybody. Just give me a thumbs up or thumbs down in the chat or something if it's too small. A bit bigger? Okay. I can do that. Just need to let's make it. Is that better? Yep. Okay, awesome. So, okay, so this is our main TS file. This is the file that Angular is going to compile down kind of into the entry point for our application. So if you remember, the previous way to do this was platform browser dynamic, bootstrap module, and then we add our app module. We don't have an app module yet, so let's create one. Now, this is a module, so we'll do ng module and then bootstrap. We don't have our app component yet, so we'll create that after we. So there's our app module. Now, we will come back to this and remove the app module entirely, but for now we do need it. So let's add that to our bootstrap call. And then let's add our app component. So this is the root component that's going to be rendered into the DOM as our root. So our root is demo root. Okay, so export class app component. Why do you not like that? Oh, template. Of course, we need something to actually render. So let's just say hello world. Okay, let's bootstrap that and save that. We need to import a couple of dependencies. And I have the dev server running here, so we should be seeing live reloading changes. Angular has a really, really awesome, like one of the best CLIs out there. So yeah, so you can see here, I guess I can probably zoom in here as well. There we go. So we can see that changed. There we go. So we can see that it's all working correctly. So we're good here. I think I need to add it to declarations for some reason, even though it's working. Yeah. Okay. Okay. So that's all working now. Let's add the router module. So remember how we were talking about the router module before and doing the for root and all that kind of stuff. So router module.for root, we're going to add some routes and then our component. So we don't have a component yet. So let's go create a routed component the old way. So we're going to need a component file, and we're going to need a module file, and we're going to need an HTML file, and we're going to need a SCSS file. So you can see how this already, this is a lot of files, right? So let's go to our component and make this template URL, and then our styles. Now with Angular, there's actually tons of code generators, so you don't need to do all of this manually. I'm just doing it to show everybody. But if you use the Angular CLI, or if you use a tool like NX, for example, NX is a really, really awesome tool. I actually use it to generate this empty workspace. Then you have code generators that'll just scaffold all of this for you, which is fantastic. Okay, so we now have our, call it old, our old way of doing things. Routed component. And what we're going to need to do is put a router outlet here, so that Angular knows to render the oh, I put in the wrong component. So it's supposed to be in the app component. Here we go. So now what we're actually doing is we're actually using the Angular router to show our hello world. So it's what it's doing is it's bootstrapping the app component and then matching the URL pattern here against this route, this path here, and then showing this component because we're just at the root path. So that's now working. That's exactly what we want to be happening here. So let's go a little bit deeper and add, let's add some state. So I guess we don't really need to go into NGRX here. Let's just create a pipe. So let's do, let's call it add UC Davis pipe. So what we're going to do is we're going to create a pipe to append UC Davis onto any string that gets passed in. So we need that. We know our value is going to be a string. So now what we have is we have our pipe, but it's not standalone, right? So we want to have a module for it as well. UC Davis module. See how much of a burden this could be. So our declarations would be add UC Davis pipe. We want to export it so that people that import this module are able to use it. Now let's import it into our routed module. And then what we do is we just go like add UC Davis pipe, but why do you not want to? Oh yeah, right, we need to do this. Oh, it's not actually called pipe, that's why. Okay, there we go. So now what this is doing is we're saying take the string, pipe it into our add UC Davis pipe, and you can see that our hello world is now appended with UC Davis. So that's pretty useful there. And then our styles. So let's just say we want this text. So class, title, for example, to be red. I don't know what your guys' school colors are, but we're just going to go with red. Okay, so there we go. So now we have our router module, our app module, our app component, our routed component, HTML, SCSS, our pipe, all that kind of stuff. So let's add a resolver now. So let's say that or a guard sorry. Let's say there's a guard that we want to confirm that we want to navigate to the page that says hello world UC Davis. So let's create a guard. Guards are injectables so that they can exist within the dependency system. Implements can activate. So our can activate. We don't need all of these typings. We're just going to go Boolean. We don't actually need these either. Okay, so we want to say hi. So what this is doing is we created a guard that will run when a route goes to be activated and ask, can we actually activate this? And this confirm is just built into browsers. It'll pop up a little pop-up in the browser and give you a yes or a no. So let's provide this. Providers. And then on the path, what we can do is go can activate and then add the confirm guard. There we go. So we reloaded. Our little dialog says, do you want to say hi? I say, okay. And then the route will actually load. So what's happening here is navigation has stopped before we get to this path. Like we've gotten to this path, and now this guard has to check and say, am I allowed to continue rendering my navigation down the tree? So if we say cancel, it won't render anything below that. So thus it won't render the routed component. But if we say yes, it will render the routed component. So that's how guards work. Resolvers work a very similar way. You would just do, resolve and then add some resolvers there, and then that would be available on the route data within your components. The route data is just pulled from the Angular router. It's just one of the other features there. So now we have an application using single component Angular modules in general, pipes, multiple files for components, all that kind of stuff. So let's go through this and make them standalone now so that we can see the difference. So let's see this all on one screen. Okay, so first off, the pipe. We don't need this module, so let's get rid of it. Okay, but that means now our application does not know how to resolve this dependency. So if we add standalone true here, now what we can do is instead of having this module, we just import the pipe directly. And it still works. So now we completely removed a file from our application, and we completely removed 9 lines of code or whatever was in there, right? So now with the routed component, let's make that a single file component. So our component is here. Here's the HTML, and then here's the SCSS, right? So let's change this to the template. Well, we can just pop that in there and then delete our HTML file. Still works. There we go. We just completely removed the file. Now with styles, we can do something very similar. There's our styles. Delete this file. There we go. Still red. That's good. We still have this module though, right? We don't want this module. So let's get rid of this module entirely. Make our component standalone. And now that we remove the module, we have this dependency on the add UC Davis pipe. So we need to import this back into the component. So all we have to do is just import add UC Davis pipe here, just like we had in the module. The imports array, providers array are just in the at component decorator now, whereas they used to be in the modules. So we just completely removed a file. Again, we removed, 9 lines of code, whatever. Now, since we don't have this routed module in our app module, we don't need it anymore. We don't need it anymore. And we can just route directly to this route, the routed component. Boom. One less file to worry about, one less set of lines to worry about. So we have our standalone pipe, standalone component, but we still have this app component and our app module. So what do we want to do with that? Well, we want to change our platform browser dynamic to instead bootstrap application and just bootstrap our app component. Now, what do we have in our app module right now that we need? Well, we have our router, and remember from the slides, we no longer need to use the router module. We can if we want, but we don't need to because there is a provide router function, right? So our provide router function, just pop those routes in there. We don't need that anymore. And then we can just get rid of this app module entirely. Clean that up. Why is it complaining? Oh yeah, right. Because our app component, we need to make standalone. And then import our router outlet so that we know that this component has access to this router outlet. Now, why is this failing? Well, before we were providing this confirm guard in the Angular module, that the app module, right? So we said we have access to this guard. So what we can do, which is really cool with Angular now, is instead of having injectable and class-based guards, we can create functional guards. So we can do where it's just a plain function. And then we do confirm. Oh no, we just want this here, right? Just delete this entirely and just put that there. Look at that. Our confirm question dialog is back. You can hit yes, and our text is being displayed. So think about how much code that would save by not needing that add injectable, defining the guard and all that kind of stuff. We just have a simple function that Angular is now calling. We don't need to provide it. We can just supply it to the can activate. What's really cool about these guards is you can actually use the inject function within them, even though they're just plain functions. So you can inject all of your dependencies. Say you have like an HTTP service that needs to call some authentication endpoint to actually confirm that the user is who they say they are. You can inject that into this functional guard and then use that to call your API to get your user. So that is it. We just built an entire Angular application using the old method and then converted it to using all the different standalone APIs. We didn't touch the inject function. We don't have a huge amount of time. I want to make sure that we leave some time for questions. But that's how you build an Angular application with standalone APIs. Thank you. Here's some helpful links. I think, again, I will supply these slides to everybody. So you will be getting them and you'll be getting all these links. But I would like to open the floor for questions now so that we can chat about all of this. I don't know if you guys want to unmute and ask them or just ask them in the chat and then I can go through some stuff. Or if the organizers have a different idea. No questions? I know I ripped through that pretty quickly, so I apologize if some of those topics and concepts were a little much, since I know not many people have used Angular here. How do we use guards in practice? Great question. So usually what I like, one of the main uses that we find right now is authentication. So usually, let's say in our routing structure, we would have, say, like a login path, right? And then the rest of it, component here, right? And then we would have our, say, dashboard path, and then our component. Dashboard requires you to be authenticated, right? You need to be logged in. So what you would be able to do is add, can activate, and then add a guard here that would take some authentication tokens stored in the cookies or the local storage or cache or whatever it is, call to an API, check to see if they're logged in. And then if they're not logged in, redirect them back to the login page. One of the really cool things with guards is you can, instead of just returning a true or false to allow them to navigate or not, you can return in Angular what's called a URL tree, a URL tree. And that'll say, and then Angular will say, okay, well, if I receive one of those backs, I won't resolve this route, but I'll take them to the route that was returned to me. So in the dashboard case, if they're not logged in, you just return a URL tree of /login, and then they will end up at the login page, or vice versa, right? You can then also create a guard for the login path that says, if they're logged in, then return a URL tree to the dashboard so that they're taken right to the dashboard rather than having to log in again. So that's one case. Another one is like, if you have, say, you have some entity and in the URL you have an ID, you can write a guard to parse out whatever ends up being here, check to see if, make a, say, an HTTP call to your server to see if that entity exists. If it does, allow them to continue, return true to the router guard, or return false, or URL tree, be like, no, sorry, resource not found, and take them to a 404 page, something like that. Next question, can I share my experience working with Angular and how it has helped me in my previous projects? So funny story. I have been with Trellis for, it's coming up on 6, it'll be 6 years in November. I had never built, I co-founded Trellis, but before this, I had never built a website ever. So Trellis was the start of my web development journey. So I've only ever used Angular to build websites. I've never built anything with React or Vue or Svelte or Quick or anything like that. So I just went really deep into Angular. Obviously, I really liked it. I'm now an Angular GDE, so Google has, recognized me for that. But I feel like with Angular, one of the benefits is its opinionated nature. It has a particular way of doing things, and some people don't like that. But I do find that it helps structure applications well, build applications really well, because it puts guardrails up, right? And those are just because there's guardrails doesn't mean that you're hindered. It just helps you steer you to the right architecture a little bit better. So I wouldn't say that working with Angular has helped in my previous projects, but it has helped me moving forward just to understand how everything's set up. Also, all of our backends are built in Nest.js. So that's another technology that I use, which is a full TypeScript-based framework, but it leans on the concepts in Angular quite a bit. It has, decorators for dependency injection. It has controllers or component, like the backend version of a component. It's an MVC framework, a model view controller framework. So Angular, I actually started working with both of them at the exact same time, and I had to learn them both from scratch. So learning both simultaneously really helped. Super new to Angular, are there any courses or tutorials I would recommend? Yes, there absolutely is. There's this one fantastic course from my friend Santosh that is on Free Code Camp. I will find the link and send it in the chat or send it to the organizers afterwards. I just gotta find where he has done it. Maybe it's on YouTube. Yeah, anyway, so Santosh's free code camp would be the best one that I can think of for sure. Nope, I'll find it and send it to everybody. The other thing, the docs are fantastic. They can be a little technical at times, but they are super good. I don't know why I can't find this free code camp link here. I'll find it. Any other questions while I go hunting for Santosh's free code camp tutorial? Don't know. Okay, well, yeah. Is there anything else anybody would like me to cover? Okay. Well, thank you for having me.